video. We're going to explore the basic steps and mechanics of doing a code kata. And for you who do not yet know, code kata is an exercise to help us understand and familiarize the basic steps and theories of doing TDD, which is test-driven development. So in today's code kata, we'll be doing the Roman numeral converter. If you don't know, look it up in Google. And we're going to follow the red-green reflector rule. And before we start, I just want to credit Weirich at Neo Innovation, because the flow of this kata is basically stolen from his presentation at Red Dot Ruby conference in 2013. So let's get started. So I have a folder, and inside I have a couple of files. So I have RSpec files with a couple of RSpec options. I have a rake file that allows me to run rake, and the default rake class is RSpec. And I have a RSpec stub, which I using Jim's RSpec given gem, and I'll have the Roman numeral converter required, and also I'll be using natural assertions because the specs that we are doing are quite simple. And then we have a blank class file called Roman numeral converter. So now the first thing we need to do is to step up the spec, because we need to do our first test. And the way of doing it is that we have to do given, let's get rid of this, converter. There's a Roman numeral converter dot convert, and then I want the converter dot convert. Sorry, new should not be nil. And let's run tests, and it fails because it tells me that doesn't know the convert function because we haven't write it yet. So let's go and do it. So let's write the convert function, and the convert function takes an argument, and because it shouldn't be nil, let's just return true. And there we go. We have first green. Okay, so in Roman numeral converter, so we have glyphs. So we will think we can start with 1, and we can do this because 1 should equals to I. And I think I'm going to delete this now because this test doesn't really tell me anything from this point onwards. So let's get our red. So it fails because it tells me I need an I. It needs to be returning an I. Now it's time to get our code to give us an I. That's just that simple. Sorry about that. There we go, we have our green. Now let's do 2. So if I do converter.convert 2, it should give me 2i. Now, how should we go about this? I think we should do this because in Ruby there's a neat little function that lets us multiply the string. So if I just do this, it should give me 2 i's, right? Sorry, I didn't do the red. So let's do the red. So I should write my spec, know that it's failing, then fix it, because a test without failing is not a real test. Now let's do 3. I think this will definitely work, right? So it will work. Now let's go on to 4. And I think we're not going to do 4 first because I know through my knowledge of the Roman numeral conversion, that 4 is a special case, and 4 is not a glyph, because 4 is a combination of a glyph I and a glyph V. So I don't think I want to tackle this first. I want to tackle all the glyphs first. So I'll do 5. So 5, convert to 5, and yeah. So we have 5 I's, of course. So now it's time to go and make our code work, and I think I can just do this. So if n equals to 5, I'll let it return an v, else I'll just do this. Yay! So it's very important that we know that, of course, this is not the final solution for the converter, but it's important that we know that this solution is fulfilling our spec. So we are writing solution that is minimal, that only solves the spec, and sometimes, and most of the time, you will find that the solution is something that you didn't expect from the beginning, because we are allowing the test to drive the solution, hence TDD. Now, we have 5, now let's do 6. 6 won't work because it gives us, what, 6 eyes? So I think it's time that we need to look at the code again. And because it is a combination of 2 glyphs, I think I need a string to concatenate them together. So I'll do something like this. I'll do a result. And because this is 6, I think I need a v as well. So I'll just do this. I'll just append it. And I don't think I need that much I, so I need to reduce the number of n by 5. And then whatever's left is the number of i's. So let's see. Oops, we broke it. Why did we broke it? Yeah, we didn't return it. So, and I forgot to append it. That's why we do TDD. Yep. So 6 is fine. I think 7 would be fine because I think we are pretty good with our problem here. Great. So it's fine now, and now we can do 9, which is a special case again, and I think I don't want to do this right now. My computer is getting really slow. So let's do 10. And how do we do this? So I think 10 is something similar like 5, right? So I think I can do this and duplicate this. I'll change this to 10. 10. It looks good, and let's see. Yay! So I think we're good, and we've covered 3 glyphs. We covered I, we covered V, and we covered X. Now I think it's time that we come back and cover this. What do you think? I think that this special case can be just like a glyph, and if I do this, it would work for me, I think. So let's try it. It's work. Yay! Oops, forgot the red again. So let's go back and do this. It's failing because I want to give into a habit of knowing what I need to solve, because I need to solve this to give me back IB. So now it gives me back the IB. Cool. So now let's go on to 9. And I think it needs to be here because it needs to be lesser than 10 but not greater than 5, sorry, and greater than 5. So this is ix. Sorry, did I do that? No, I didn't. So red, green. Cool. Now we were all doing red green here, so what about refactor? So let's do some refactoring. I think we have a lot of duplication in the code, so I think all this can be the same, right? Because I can just loop through this. But what about this? I think I can change this to something like this. And the best way of exposing duplication is to make the duplication apparent. So I can do this. So I can do if and greater equals to 1, right? And then what result? I append I, and then n equals to n minus 1, and then I return the result. Does it work? No, it breaks everything because I think it just run once. So I think I need a while. So I think if I run while, this will work. Yay! Okay, so another red green. So come back and refactor, and I think this will work as well. I think. Yes, so now the duplication is quite apparent, and now I need to do this by just let's give it like conversion table equals to an array of the digit, for example, and the Roman numeral. And the next one is 9541. So it's 9541, and this is 1459. And here I'll do conversion table each do the number and what glyph. And I can just copy and paste this in, right? And this will be the number, and this will be the glyph. And I can remove all this stuff. Does it work? Yay! So I think we are pretty covered here, because I think if, let's say, we have any special case or any special glyph, it will work. And let's try again. I think C is 100. So if I do C, this is what I need to do. So I need the red to give me back like 10x. So I need to do this. This is C, and it works. So I think everything else will kind of be the same from now on. Like CD is a special case, and D is 500 because